So it's in the first quadrant. Y equals x cubed. Y equals 2x minus, where'd you go? X squared. So I know I'm living in the first quadrant. So, of course, like always, one place to start is where they meet, if they do. So if I set them equal to each other, see what happens. Oh my gosh. All right, I'm just going to do it. X squared plus x minus 2x, x plus 2, x minus 1, 0. So you get x equals 0, negative 2, and 1. Which of those do you don't care about? Yeah, we saw a problem like this. It was 1 to 5, whatever it was. There was a problem like this where where they meet somewhere outside. It's in the first quadrant, so screw the negative 2. So they meet at 0 and 1. X cubed is 1, that's cubed. And this at 1 is 1. X cubed does like this. What does this do? Where's its vertex? No vertex on x cubed. Where's this guy's vertex? There's x cubed already. I got x cubed up there. All right, x cubed does this. There's that piece. Bam. Where's this guy's vertex? You're in calculus. If you forgot. How do you find this guy's vertex? You take a derivative. 2 minus 2x that equal to 0. You get x is 1. And where is its intercepts? X-intercepts. 0 and 2. So its intercepts is 0 and 2, and its vertex is there, so it does like this. And who cares about this part? I mean, do you see, those are the things you're supposed to come out of pre-calc, just be able to do kind of quickly for yourself. That is a rough sketch, but it is actually a decently accurate rough sketch. Not perfectly detailed, but decently accurate. I can tell who's on top, I can tell who's on the bottom, I can tell the rough shape of it. Right? Okay. So that was the first step of this problem, was just getting a little rough sketch and figuring out what the limits might be eventually. Can't go wrong. It's going to be 0 to 1 for something. So part A just asks me what's the area of this. This is where people start to overthink it. Just the area. This is before chapter 6 then. How do I find the area between those two curves? The area between the curves. So it'll be the integral from 0 to 1. Who's on top? Yeah. The down parabola's on top. This is going to be x cubed. Don't overthink it. This is not shells or spheres or discs or washers or... This is just 2x minus x squared minus x cubed. F of x minus g of x, right? The area between the two. That's why I like this problem, is it gives you a problem. It should be easy, but you try to over-harden it. You're like, that can't be what they mean. We got x squared minus x cubed over 3 minus x to the 4th over 4 from 0 to 1, which kicks ass. So I get 1 minus a third minus a fourth. That's 4, 7 twelfths, so I get 5 twelfths. And then that's a nice one to check in the calculator if you remember how to do that. Now part B says, rotate that around the x-axis. What's really interesting is, do you think that if you rotate around the x-axis and rotate around the y-axis, will those volumes be the same or will they be different? And the reason you think they're the same is because the picture is a rough sketch. Is the curvature of this the same as the curvature of that? So that's going to actually cause a slight difference. So let's try it out. Try to set it up, rotating this around the x-axis. Figure out what method you would use. So what method are you guys using? What are these functions of? X. Can you solve this one for x? Can you solve this for x and get it as a function of y? Oh, hell no. If I wanted to use shells, and I'm going around the x-axis, it would have to be integral dy. All right, screw that. I don't want to get this as functions of y, so pretty much I have to use washers. That's the process of elimination you go through. Now sometimes there are definitely functions you can use both methods on. But this is a good one. There's one method you do not want to use. So washers allows me to do integral dx, and they're already functions of x. Yay. So, inner radius is obviously x cubed. Outer radius is 2x minus x squared. So then you got your 2x minus x squared minus x cubed squared, which is x6. Going from what to what?
0 to 1.
Yeah, you can't go wrong there. So see pi, 0 to 1, and you're like, watch, I'll figure out a way. 4x squared, and you just FOIL this thing out. Minus 4x cubed, is there? Plus x to the 4th, minus x to the 6th. Polynomial 0 to 1 limits. I mean, that's the best integral problem to have. So 4x cubed over 3 minus x to the 4th, that's nice, plus x5 over 5 minus x7 over 7 from 0 to 1. So I get 4/3 minus 1 plus 1/5 minus 1/7. This will be 1/3 7 minus 5 is 2/35, so plus 2/35, I believe. And then you get 35 plus 6 is 41 over 105. Is that right? Wow. Maybe. Yep, looks right. How can you check this? You put this into Y1. You do second calc, number 7 from 0 to 1. And that should come out to be 41 divided by 105. You guys, anybody get something different there? It almost doesn't matter, to be honest. I don't know if you really understand what I mean when I say that. It doesn't mean the math doesn't matter. It just means this is the hard concept. This is the plug and chug shit you should know already, so who cares? Okay. And then part C is the same problem. This should be kind of expected, except they want you to do it around the y-axis. So what's that going to mean for my process I want to use? Totally shells, because again, I still want dx, but if I'm going around the y, washers would require dy. So screw washer stuff. Keep my x stuff. So how's that? What do I need to figure out then? I always just remember this is the basic setup here, right? For shells. 2 pi RH. That's what you need to remember for shells. Or however you got to memorize. Keep that if it's going. So if you draw in a rectangle, how will it look? Will it be standing or laying down? Standing. It's got to be standing. It's got to be parallel to the axis you're rotating around. That's how you get a shell. If it was perpendicular to the axis you're rotating around, you get a disc. You're not using discs. Oops. And I locate it on the axis perpendicular to this. So that's going to be, this is going to be the location. So what is R going to be? Well, R is going to be X. It's not, if I rotated around this axis -1, then it would have been X plus 1. You still have to adjust it if I change my axis of rotation. It always has to be adjusted. Whatever that distance from the axis is has to change if I move my axis around. But I didn't. Yay. How tall is it? So R is X. How tall is this? Yeah, this minus this. Kick ass. Doesn't that, please let that just make sense. You draw the radius in and you say, how long is that thing I just drew? You put the rectangle in and you say, how tall is that thing I just drew? I mean, that's an actual part of this process. So I got 2 pi, it's going 0 to 1 no matter what the shit, right? R is X, and H is the difference in those. So let's see, 2 pi, 2x squared minus x cubed minus x4. By the way, there were maybe, like, I don't remember, 4 people or something that did this, which is 4 too many. You cannot say you integral of this is x squared over 2 times x squared minus x cubed over 3. When you take the derivative of a product, it involves a couple of steps. So the integral of a product, no, you can't. There's no product rule for integration. Integration has an answer to the product rule. Integration has an answer to the chain rule, but there is no corresponding rule like that for integration. You have to simplify what you're dealing with. And now it's easy. Hopefully, right? Still from 0 to 1, which is nice. So I get 2 pi times 2/3, 1/4. So I get, let's see, 8 minus 3 is 5/12. What did I just do? 8 minus 3, that's good. 5/12, yeah. Minus 1/5 And that's 25 minus 12 is 13/60ths, and then I get 26 pi over 60. I could have just done 13 pi over 30, which certainly is different than that. 39/90ths. 39/90ths. 52. Anyway, I'll stop. Trying to see how far off these are. These are different, but they're not that far off. Again, you don't have to understand the thing I said earlier, but it is because the curvature is different. So that one's further away from that axis when I do this. That one's further away when I do this. The different curvature is going to cause more or less volume. That's why these numbers are not the same. That's kind of a cool idea. Okay, I like it. Was there another one in that list?
25.
Oh, yeah. So I think you should have seen at least one problem like this in the homework. If past Jeff did what I wanted him to do. Height of a monument is 20 meters. Horizontal cross-section at a distance X meters from the top. So I think it goes like this. X meters from the top. Oops. Let's put in it. Is an equilateral triangle. So if the cross-section, so if I do this and turn and flip it, it looks like this. Right? Okay. What did it say? With side 1/4 X meters. So the further you are away from the top, the larger the sides of that triangle get. And of course, when X is 0, you're just at a point. There are no lengths of any sides. It's just a point. So it's kind of nice. So let's see. Now, all right. So first question is a simple question. What is X going from to? 0 to 20. Is that cool? Because I'm going to start at the top and go to the bottom. So I'm going to integrate from 0 to 20. Now, why am I integrating? Because I know every area, what it is. So if I add up all of the areas, and of course, how many areas are we talking about? How many equilateral triangle slices do we have? An infinite number. So how do I handle that? Integral. So I'm going to add up all these infinitesimal slices. There's an infinite number of them, so an integral is the infinite sum. So I'm going to go from 0 away from the top to 20 away from the top. Now, what is the area of this? Do you know your equilateral triangle area formula? I don't. So you got to create it. Right? If you don't want to work with this shit, you can actually just do this. S, S, S. S is a bad choice, Jeff. Let's do, Y is a bad choice. Let's just use this. Everything's a bad choice except for this. I need to know the height of this, right? All right, so let me just look at that. Let me look at this half of a slice thing here. This is 1/4 X. This is 1/8 X. Can you figure out the height? Of course you can. Oh, you're gonna love this problem. Every step is simple, but it's just knowing what steps to do and what order is the hard part. But the idea is exactly what we've been doing. I'm going to figure out the area X away. That's like your representative triangle area. And then if I integrate from the beginning to the end, all those areas, I'm going to end up with the volume it goes through. So what is the height? Yeah, so 1/16 X squared minus 1/64 X squared, which is square root of 3/64 X squared, which is X square root of 3 over 8. That's the height. you're going to love this problem. It's not calculus we're doing right now, by the way. This is just, just ordinary math. What's the volume, the area of this triangle now? 1/2 the base times the height. So that's going to be, it looks like it's x squared, square root of 3 over 64. Funkydelic. All right, and so that's the expression that I'm going to integrate. Take every triangle's area. Here's every triangle's area. Let x go from the smallest to the biggest amount. And I get the volume of this thing. Yeah, so now you've got, what's the constants in here, by the way? It's square root of 3 over 64, right? Times the integral of x squared is x cubed over 3. 0 to 20. Yeah. What's happening? So is that equal? Root 3 over 64 is a constant. Integral x squared is x cubed over 3. From 0 to 20. 20 cubed is 8,000. So you get 8,000. Square root of 3 over 64 times 3. These reduce a bit. So you get rad 3, 1,000 rad 3 over 24. That reduces a bit more, blah, blah, blah.
I'm a little confused about the x to the third over 3 part.
So if you take these out of the way, take these out,
Yeah.
there's your real x-dependent part. So the integral of x squared is,
Oh,
Yeah.
okay.
so get the constants out of the way so you can focus on what it really is. Now, let me see. I should just stop saying what I was about to say, which was, bear with me for a second. I want to... So this is like a... let me see if this will work out. Maybe this is something I'll do by myself. It's basically a pyramid with equilateral triangle base. So it should be 1/3 the area of the base times the height. Should be the volume. So you can kind of check it by doing that. There's a geometrical formula for the volume of a pyramid. And the definition of a pyramid is whatever shaped base, all the corners go to a single point. For me, that's good. So, and to figure out what the actual volume would be, it's just the volume, this would even be even better, Jeff. Volume of what it was cut out of, 1/3 of that. Right? So if I had a rectangular base, I could just check my answer. Here I got an equilateral base. So this will be 1/3, the volume of this would be 1/3, the area of the base, which we give big ass B, means area of the base, times the height. I can check my answer by just doing it that way instead. You don't have to right now, but you could. In fact, I mean, it's kind of trivial then, because at the base, that's when x is 20, right? So the area of the base triangle is 20 rad 3 over 8. 1/3 of that times 20, and you can check to see if we get the same thing we do there when we reduce. Okay. Was there another one off that?
31.
31? Oh yeah, I want to give you at least one average value problem. And as long as you can integrate, those are easy. Somebody did I didn't have any average questions on the test. I didn't ask you to find the average value. Somebody divided by stuff, and they didn't have to. But basically, average value of f on a to b is 1 over b minus a, integral a to b, f of x dx. This really is add them all up, divide by how many there are. That's how you always find the average, right? Add them all up, divide by how many there are. So for this problem, it says average value of secant squared t on 0 to pi over 4. Yeah. So you're going to integrate 0 to pi over 4. You're going to do 1 over pi over 4 minus 0. You're just going to do that. What is the interval of secant squared? From 0 to pi over 4. And then you just get, what's tangent of pi over 4? 1. And tangent is 0? 0. That reminds me, nobody had a question about that problem. A decent number of people got that problem right, the interval of tangent. Or cotangent, depending on which version you had. But again, one big idea that we understand now is, I can't remember what I had there, but let me not make a T. Tangent, of course, is sine over cosine. And then what method can you use? Is there a function that's stuck somewhere whose derivative is in there also? What's the stuck function, would you say? What function is stuck somewhere? Does that not make sense when I say that? Cosine is stuck on the bottom. Oh, yes? So if I was solving this equation, that's easy. If I was solving this equation, that's a little harder because x is stuck on the bottom. And then the first thing you do is unstick it. You multiply by it, right? So I say what's stuck somewhere. So it's either inside something else or it's under something else, right? That's the stuck part. So if you let u equal cosine x, what's du? Negative sine x dx. And isn't that basically what I have? Just now I do. Then negative integral. That's du and that's u. So 1 over u du. Blah, blah, blah. So u sub lets you do integration of functions if you rewrite them. For example, tangent. Sine over cosine, u sub comes in. Says I got this. Oh, let me give you that. Give you the answer key for this thing. I know you probably appreciate seeing more than just the answer, but you also are like, can't you hire somebody to write for you?
question. What do you think would be the best way to study for tonight? To go over each section, all these sections?
I'd say the best way to study is, start with the practice final and just kind of eyeball and say, okay, that one I have an idea what to do. And find the ones that you're like, I have no idea how to do them. Find out what section they came from and review that process. And then go back to the ones that you thought you knew how to do and try them out real quick. Don't try the problems on the practice final more than twice. I think I've said that before, because then you start to know the problem itself and not the process. I'm not going to give you the same problem. And then look at the old tests and see what kind of questions I ask, because I normally try to ask, the same kind of vein of questions. I don't give you like something out of nowhere, believe it or not, on the final. I don't think finals are supposed to be slap you in the face. I think finals are supposed to be show me I understand the basic concepts, right? I'm not saying it's going to be crazy easy, but I'm not going to try to make it just stupid hard just because. Okay, I've had teachers do that before, and they're like, I just want to see who could do this.
Are there any sections that we can not worry about or no?
I love that question. You do not have to worry about chapter 9. No, I'm sorry. That was a good one. That's it. Anything and everything can be on there, including things that come from the review of stuff that came before. So when you hear the statement, you're like, so you're saying everything about math I've ever seen can be on there? In a way, yes. I'm not going to give you some obscure something we never even saw in class. I'm not even going to give you a partial fraction problem. I'm going to let that. I just want you guys to not forget it, or if you've never seen it before, I desperately had to show it to you because it is going to become a thing in future classes if you go much further. If you don't, then hey, there's something I wanted you to know that you don't have to worry about. If you don't have to go any further in math. With that said, like 1A talks about the limit definition of derivatives. I wouldn't give you something more complicated than one I gave you. I'm not going to give you something that's really, really weird setup. I just got to make sure that you remember that idea, where things came from that we're using. I think what I would normally do is I'd write. When I studied, I got to the point where if you said something like second derivative test, I tell you what section it was in, because I list the topics and then I check them off as I get comfortable with them. I'm like, I know what that means. I know how to do that. I know when to do this. So when I say absolute max and min, that's the easy problem. That's when you find the critical numbers and then just plug those in with the endpoints and see who wins. Who wins the prize for the biggest and who wins the prize for the smallest. Right? Some of you guys are doing like sign diagrams for absolute. No. Sign diagrams don't mean shit. It's just who's the biggest, who's the smallest. Where could those happen? At critical numbers or endpoints? So you just plug them in and check them. So remember, absolute max and min are the easier questions. It's the local maxes and mins that suck. Then you got to make the sign diagram this here. Right? Absolute max. If you have a local max for an absolute and there's another one higher, well, that one's going to be obviously a larger value than that one. I don't have to know that it's. Does that make sense? All I have to care about is what the output is at those points. All right. Somebody was telling me a really good thing. If you have certain derivatives that you haven't gotten in your brain yet, you just write them over and over and over. It's just like a foreign language, right? Or even taking biology or something, when you have to remember how to spell all the different phylums and all this shit. You'd write it a few times so it becomes normal to you. If you don't see it enough, you don't know what normal is, you're going to misspell it. And at this point, if you haven't done this for yourself yet, I'm going to ask questions where I don't want decimal answers. I want the exact answer. So if you don't know how to do cosine of pi over 3 at this point, I don't know what to do. Okay? But you know it's going to be on there. And I don't want to see no 0.707. 0.707 is rad 2 over 2, by the way. Right? So I want to see rad 2 over 2. I don't want to see 0.707. I don't care about that. I don't know what else to tell you. I mean, there's a decent idea about how to study for this. You don't have to do every problem on the practice final. I would start with the ones you feel the least comfortable with. Or I understand as a student, sometimes you're like, I don't have that kind of time. I'm just going to skip that problem. I got a half grasp on this. Let me start with that, make it a full grasp, right? I mean, you portion your time out as you need to. I totally remember doing that myself. Oh yeah, that problem, I'm going to skip the shit out of that one. And I'm not saying you should. I'm not condoning that. But I mean, you got to be realistic with yourself, with the time you got, right? What else can I tell you in general? I mean, students get upset that, and this is a larger issue than just I'm able to talk about right now, but a part of this is being able to think through the problem. Draw what you need to for yourself. You can't go, I've never seen this problem before. Well, of course you haven't. It's on a test. So nowadays there seems to be more and more of a feeling of, if you haven't shown me exactly how to do this problem, then you shouldn't be able to ask me this problem. That's insane. There's an idea and how it's applied, right? So sometimes you're going to have to just draw out what it is from the problem. Sort of like that bicycle and balloon problem. Right? Remember that problem? I'm sure you guys do. It was all about drawing it out and then realizing you also draw it out 3 or 4 seconds later to really get the full idea of where things are. Let 3 seconds go by, that things have moved, that kind of thing. We had never done that problem before, but it used everything we had discussed in the problems. So, and I like that kind of problem. So, all right. So I'm never trying to trick you, but I have to test your ability to use a concept fully in a problem. I'm not really making you feel better. I'm sorry. I'm not going to try to trick you. I am going to try to make sure you understand the basic concepts, but I will tell you there will be some problems where you're going to draw it out and think about it. Sorry.
Can you go over 2A on the practice plan?
Oh shit, where are you? There you are. Oh, it was 2A. Oh yeah, okay. So I chose to rewrite it a little bit. What did it start off as?
ln of x squared minus x cubed.
And you had to take the derivative, right, or something?
Yeah.
All right. So if you take the derivative the way it is, it's a chain rule and a chain rule and a chain. Oh my God. It's something inside of something inside of something. But ln has all these beautiful properties. So how many of you guys try this and just try to do it directly? You started taking derivatives right now. Anybody? It's okay if you did. It's completely fine. Sort of? All right, so let's try to do that. The derivative would be, what's the primary thing? ln. So that guy's derivative is going to be 1 over the thing times the derivative of the thing. Right? Get out of there, cube. Get in there like that. There you go, buddy. No, it isn't. It is that. Ooh, it's even worse than that. Okay. So that piece is just sitting there waiting. This is why I find it crazy that people don't know where to stop. It's like, how do I know to keep going? Because I got a prime right there. Okay, I keep going. All right. So how do I take this guy's derivative? Bring down to 3 times x squared minus x. Is there an inside that I have to do something with? Yes. Okay, so times the derivative of that. Do you see how already 2 of these cancel? Okay. So I have 1 over cube times 3x squared plus x squared times Is there any inside? No. I don't know. There's no like, when do I stop? No, there's none of that. Of course you stop there. There's no other inside. And now I can kill 2 of these. Right? And so this will be like, what do you get? Yeah, 6x minus 3 over x squared minus x. Right? All right. And I love it. You guys are looking at my answer going, you didn't get that. Yes, I did. So, if instead I simplify the thing I'm working with. So bring the 3 down. What other thing did I do? I factored the inside, and then I used the property of logarithms that says the log of a product is the sum of the logs. Hopefully I wrote this correctly. We'll see. Logs are powers. The property of logs are the same as the property of powers. When I'm multiplying things, I add the powers. That's all it's saying. And now this derivative is going to be a lot easier. Let me just put a 3 next to both of these things. Can't remember what I did. So this will be 3 over x plus 3 over x minus 1. Which, if you got LCD, it would be 3x minus 3 plus 3x over x times x minus 1, which is 6x minus 3 over x squared minus x, which is what this is. It just was a hell of a lot easier. Yeah. So again, it's doable if you miss that you can simplify it. So it's not like you're going to totally get it wrong if you don't realize you simplify. It's just going to take you longer. If you do this on every problem and then you're like, I didn't have time to finish, I'm like, that's because you made things hard for yourself. Simplify if you can first. Of course. There was a problem where it was x squared minus 4x plus 5 over x minus 1, something like that. And you could reduce that. You just reduce it. You just factor the top and kill. Simplify the thing you're trying to work with. Seems to have been a common thread throughout the semester. I don't know if you've noticed that. So you learn a process to use on something, but before you do whatever the shit process, you simplify the thing you're working with. Okay. Is that cool? So that's what I did. I just used properties of logs to make it look better. Now, just because this happened on a couple people's tests, if I had to integrate this, what would you try to use? How? So, okay, I could rewrite it like this, but it doesn't really help. What do you try to use there? U sub. Now, some of you guys might already notice that ain't going to work. But why? Because when you try to do U sub, the thing you need is not there. Now, colleagues of mine, will teach people that solve for dx. But that makes you, now right now, is U sub going to work? Can we see that it's going to work? Yeah, we can see it's not going to work. It's missing the 2x piece. I can get the 2 there. Now, there was somebody who thought they could do this. Most people didn't do this, which is encouraging. Can somebody just tell me why that is completely illegal? I cannot do this. The integral is based on x. I can't move x in and out of it. The integral is based on x. I can't move x in and out of it. Otherwise, I'd make everything easy. Let me move this whole thing out. So then the integral of 1 is x. Yay! This calculus shit is easy. Does that make sense? That's why I keep saying, if it's minus a constant, who gives a shit? But I have to have the x stuff there, or else I cannot do it. So what my colleagues do is they say, solve for dx. So then you just replace dx with this, but then that makes students think that everything is doable. I can always solve for dx. Throw that shit in there, and I get u to the 1/2 du over 2x And then somehow this thing just kind of comes for the ride. It's u to the 3/2, 2/3, and there's still a, and then over 2x or something. I'm like, how does he just, what? It's du, but there's an x in there. You can't know. What is u? U is a function of x. So there's an x, and it's a function of x. You don't even know how to integrate that shit. So you have to completely replace the x's with u's. If you have any x's left, you've done something wrong. Or u sub doesn't work. Okay, so that's why I try to teach you to balance. If there was an x here, what's the only thing I'm missing then? A 2. That you can balance. You don't have to solve for dx and do it. I think that's a really dangerous thing to teach, because then students think they can do more than they can. Okay. Just in case you've seen some other method from somebody else, and you're like, I love that method, it works great. And it works a little too good. You feel like you can do everything, and then you crash and burn. Trying to remember if there was one that I thought I would get a question about. Oh, what about number 10? I think it's number 10. That one, I even forgot my point with that one at first. What is the integral for number 10?
Negative 2 to 5.
Of,
T squared over 2 plus 1.
so I got all excited. I'm like, ooh, cool, you can do long division and all that shit. But the real point of this problem, and this is a remarkably difficult thing to do, so I wouldn't do it to you. Is that a word you surreptitiously? Neato. I would kind of point out what's wrong with this integral, or why can't you do this integral? Why can't you do this integral? You could read my answer, but because what happens at a point between negative 2 and 5? What happens? It goes to infinity. It's what's called an improper integral. So it can't do it. Now, some of these actually can be done, believe it or not. You can integrate, well, the other way around is easy to kind of think about. I can integrate certain functions from like 1 to infinity of a function and get a finite answer. Get like 2. Because this goes so quickly down that it doesn't really add up to infinity. Might be a little bit of a weird thing to realize. Can you add an infinite number of numbers and come out to be less than 1? Can you? I said numbers, not whole numbers. I said numbers. Of course you can. Like I can do 0.1 plus 0.01 plus 0.001 plus 0.0001. That's going to come out to be 1/9. 0.111111, right? So as long as it goes down fast enough, when you integrate, you'll get a finite thing. So you can handle some infinities with integration. This is one that's kind of difficult to do when you have, it goes to infinity somewhere in between. You can't do that. We definitely can't do that at all. Later, you'll learn how to handle some of that kind of stuff. If you take Calc 2. So you probably want to review, like, related rates normally gets people down, optimization problems. When you see an optimization problem, if you identify it, you say, what is it I'm trying to optimize? I need to make a function for that. Because then you can attack it. So some of the guys on that one fence problem, you set up a perimeter formula, but it didn't say anything about the perimeter. I wanted the cost to be minimized. And you never set up a cost function. So how in the world could you do that? So you got to set up a function that I want optimized, and then you can attack that function with derivatives. So say I want to minimize distance. Okay, I got to set up a distance function, and then I can attack it. Maximize volume, set up a volume form, etc. Let's see, I don't know what else to tell you guys. I probably will, the number 12, I will do the same thing for you again. That kind of problem, I'm going to say verify this, verify that. So if you're running out of time or if you can't make the differentiation work, you can at least finish the problem out, right? You'll know what the critical numbers are. So don't just go, wasn't able to do the derivative, so I guess I can't do that problem. No, that's the reason I tell you, so you can at least do the rest of it. Find the critical numbers and go to town. I am a little skeptical when the graph comes out a little too nice. So it's kind of funny to hear me say that, but if it's too nice and if it's too perfect, I'm like, that didn't really come from you. So do try to just graph it from what you found, and then you can check it against the graphing calculator. And yeah, I know I haven't had a lot of people complain about this because you guys generally don't talk much, but if it's supposed to be concave down and you do something like that, I'm like, what? Right? So that I have told some people taking some points off, and you're like, what? Because what is this class all about? When you're graphing, you're being a little more specific. You're telling me something when you do this. It went from concave down to concave up, back to concave down. And if your work doesn't say that, I'm going to circle it, take points off. I have to. I don't really have to, but I am going to. I'm not trying to cop out here. It's me. Yeah.
Can you go to number 6?
Oh, let's see. Oh, good. I think I rewrote it on the key, right? Didn't really do a derivative right away. So that one started off as y to the 1/2 minus 3xy. This one here? The implicit
Yeah.
2 secant y.